The next figures we want to talk about volume for, and I'm not going to spend a long time on these, are pyramids and cones. Pyramids and cones are different than cylinders is that they come to a point. This one is sometimes mistaken for a pyramid, but it's not. It doesn't come to a single point like these pyramids. They come to a point at the top. And it is easy to find the volume of a pyramid. And it's a kind of a, if we were in class, we'd do an experiment to talk about this. But the volume of a pyramid is 1/3 area of the base times the height. In other words, if let's look at the cone. For cones and pyramids, both of these have the same formula. Kind of like cylinders really had the same formula as prisms. And that was base times the height. The pyramids and cones that come to a point have 1/3 the base times the height. If it didn't come to a point, but it had the same height, but it went straight up. If it went straight up and made something that looked more like that, a triangle on the bottom and straight up sides instead of coming to a point. And I found the volume of that, and then I took 1/3 of it, I would get the volume of the pyramid. So I would find the area of the base. In this case, that base is a triangle. Find the area of that triangle, multiply by the height, and I would have the volume of that pyramid. Same thing with a cylinder, right? If I found the area, I don't have a circle across the bottom, but I'm sorry, this is not a cylinder. This is a pyramid. Did I say cylinder? Pyramid. If I found the area of that circle, pi r squared h, right? So for a pyramid, I'm sorry, cone, can I say the right word? For a cone, the volume would be 1/3 area of that's a 2, 1/3 pi r squared, that's the area of the base, times the height. If it were a cylinder, if instead of coming to a point, it went straight up to the same height, just made a cylinder, I could find the volume of that cylinder. The cone is 1/3 of that. What we would do in class is we would look at a cylinder and a cone of the same height. We'd fill it with rice and show that 3 cones fill up a pyramid that has the same base and the same height. Okay, so if I wanted to find the volume of, let's just do it. What's the volume of this pyramid? It's a pyramid. So it's a square base. So if I want to find the area of that base, the volume of my pyramid that I have, an example pyramid, that base has was it 1.875 inches was the length of the base, and then that's the same thing, right? So the volume, what was that? That was the side of the base, and the height. Let's see, the height of this thing is, I'm gonna see how I can do this. Oh my, I'm just gonna eyeball it, folks. It's 1.5. I'm just gonna eyeball it. Right, so square pyramid here. Okay, so that would mean the volume, if it were a square prism, I would say the area of that times the height. So the area of the base is 1.875 times 1.875. And the height is 1.5, right? So this is the area of the square base It says square, S-Q-U-A-R-E, square base. Area of the square base. There's the height. And since it's a pyramid and not a prism, I'm going to find 1/3 of that number. So, 1.875 times itself times 1.5 and divide that by 3 is 1.7, I'm going to round it, 76, in this case, cubic inches. Would be the volume of this little square pyramid. What's the volume of this cone? Well, let's find the area of that base, pi r squared. The r here is, let's see, looks like it's 6 centimeters across. So my example cone, right, if I want to find the volume of this cone, it's pi r squared for the area of the base, and it looks like the diameter is 6, so r is 3. And the height, let me eyeball it again. This height is the hard one to find in terms of centimeters. Let's see. I'm going to eyeball it, folks. It is, I don't know, 4.7 centimeters. Okay, so I measured to get it. So the volume of my cone is 1/3 pi r squared. There's the radius squared times the height. Right, the area of the base. There's the area of the base right there, pi r squared. There's the height, and then 1/3 of it. 1/3 area of the base times the height. What is that? 14.1 pi cubic centimeters in this case. I know this one's running long. Let me do one more thing. The volume of a sphere. Sphere is this isn't exactly a sphere because golf balls are dimpled, but a sphere is roughly a ball like that. Standard size, I'm going to assume I have a standard size golf ball here, of a golf ball. Well, the volume of a sphere is just, I'm just going to tell you what it is. It is 4/3 pi r cubed. So for my golf ball, I know this. The standard diameter of a golf ball is 1.68 inches. Okay, so it's a sphere. And so what is its volume? The volume of a standard golf ball would be 4/3 pi r cubed. R, well, if the diameter is 1.68, that tells me that the radius is 0.84, half of that. Right? 1.68 divided by 2 is 0.84. So 0.84 cubed. And those are going to be cubic inches. What is that? 0.84 to the 3rd power on my calculator times 4/3. And then I'm going to estimate. So that times an estimate of pi is approximately 2, this is calculator manipulation here, folks, 2.48 cubic inches.